Hi, good day. I'm here again today to give you the final lecture on this series. My name is Mechanical Engineer William T. Dongo. Will be your professor for today. As I mentioned on my previous series, that I graduated mechanical engineer and work as a mechanical engineer on one of these big airline company here in San Francisco, right near to the airport. So but I'm retired now, so I'm just like doing real good time just making this training video to transmit my experience to you, to help you guys share my experience during my working life. My lecture here will be climate control and residential technology. That's residential and commercial air conditioning. The lesson will be lesson 6, testing and troubleshooting. Okay, that's diagnostic and troubleshooting. You got two types. You got the mechanical and the electrical. I did not put so much notes on the board because you just gonna rely to what my boys lecture. Okay. Diagnostic, testing, and troubleshooting. You got diagnostic and troubleshooting categories. There are two types. You got the electrical and the mechanical. And then for electrical diagnostic testing, sometimes electrical trouble symptoms have a problem that overlaps with the mechanical. That means, you know, just like when I was in the Navy, that the electrician and myself and then my group was a mechanical on a part, just like in a pump. And then the motor don't run, and then we blame the electrician that it didn't work because it's electrical component, and then they get back to us and then it's a mechanical component, and then so it's a blaming game. But it's good that you as a professional HVAC, you got to dictate what's really the real problem. Is it mechanical or electrical? So you can be so there will be no issue if ever there is who are in the management who to blame. Okay? You use your electrical meters. Can be the most valuable tools you can have. You have to thoroughly understand what all the electrical components are doing and their purpose. You have to always keep in mind the best fundamentals of electricity. That is the power source, the complete path, and the load. An electrical problem can cause mechanical problem, and vice versa. For example, a fan motor that overload and stop in the evaporator section will cause the low pressures and possible icing. You will always have to think of what is going on and how can I make it easier for troubleshooting. Okay, and follow some simple step. Is the unit a split system or is it package unit? A split system will have two power source. A package unit will have one power source. Unless it is a strip heater, then it may have two. Don't check your power unless you suspect power problem. Complaint is nothing coming on. Okay. Two things will be established if fan comes on. In the split system, evaporative fan section, high voltage, okay. Low voltage, okay. Fan relay energized, Okay, some unit at a fan time delay, and then package unit 1.1 high voltage to unit okay, and then low voltage okay. If fan doesn't come on, you look into it, starting with the next easier step. Cycle the thermostat and see if you hear anything. If nothing was heard, then you check your power and check to see why it went off. Keep in mind the 4 basic circuits that are in the basic AC unit: the compressor circuit, the outdoor fan circuit, the indoor fan circuit, the control, and the safety circuit. For example, if you don't hear the compressor come on and your fan come on, you deal only with the compressor circuit. If compressor comes on and either of the fans don't, then you deal with that particular fan circuit only. Okay, that's one example. And then we're gonna go here now to the mechanical troubleshooting. Mechanical troubleshooting, symptoms will have possible causes, and that possible causes can have other causes. That's outstanding. Possible causes, and that possible causes can have other causes. Yeah. A well-trained technician can arrive to a problem conclusion fast and efficiently. When mechanical troubleshooting a machine, you have to keep in mind the basic refrigeration fundamentals and the purpose of all the components. That's the main thing. The basic refrigeration cycle, and then the theory and the operation of how each particular equipment in the system works. You gotta be sharp into that, and then you can troubleshoot it more easily. Pressure are the best checks, but not the only one. Low side gauges reading ordinarily runs about 35 degrees cooler than your return air temperature compared to PSI. High side gauges reading ordinarily runs about 35 degrees higher than your ambient air temperature compared to PSI. Humidity and high efficiency units will make both PSI deeper. Okay. Pressure, air-cooled system. And then you got a high head pressure. Refrigerant overcharged, air in the system, non-condensable dirty condenser, insufficient air entering condenser coil, condenser obstructed, insufficient RPM on motor, incorrect fan blade fits, malfunction of condenser fan, high temperature air entering condenser, restriction on discharge side. And then you had a low head pressure. Low head pressure, refrigerant shortage, low ambient temperature, damaged valves or rods in the compressor, restricted in liquid line or suction line, and then low airflow across the evaporator. And then you got a high suction pressure, high head pressure, leaky valve reeds or blown gasket, too much air across evap coil, high loaded conditions. Okay. And then the next one we have, what we got the next one here. Then they got low suction pressure. Low suction pressure, that means you got a restricted liquid or suction line. You got low refrigerant, TXB not opening, plug capillary tubes, insufficient air across coil, and then air across coil, coil too cold. And then you got a pressure, water cooled system, high head pressure, okay? Air or non-condensable gases in the system, insufficient water through the condenser, condenser coil coated with foreign matters deposit from the water, and then refrigerant overcharge, and then you got a low head pressure. Low head pressure, too much water flowing through the condenser, water too cold, undercharged. And then C, you got a high suction pressure, same as for air cooled. And then D, you got a low suction pressure, same as on the air cooled. Okay, now you got low oil pressure. Low oil pressure, you got loss of oil from the compressor due to the oil trapping in the system, compressor short cycling, insufficient oil in the system, operation at excessively low suction PSI, excessive liquid refrigeration refrigerant returning to the compressor, malfunction, oil pumps, restriction of oil pumps inlet screen, okay? And then you have the other one, refrigerated space, temperature too high. You got refrigerant shortage, restricted strainer, dryer or metering devices, improper adjusted expansion valve, ice or dirty evaporator coil, compressor malfunctioning, okay? Temperature, the next one is temperature split condenser, high temperature split, high wind blown into the condenser discharge air, air dampers reducing air quantity, dirty condenser coil, bad or motor reduced fan speed, fan blades bent, broken, etc., heavy load on system, system overcharge, air or non-condensable in system, and restricted at gas line. And then you got a lower temperature split, system lightly loaded, low refrigerant charge, and then low ambient temperature, bad compressor valves, okay? And then you got temperature split in the evaporator, high temperature split, you got dirty air filter, misadjusted air dampers, block air space, dirty coils, improper blower speed, excessive oil in evaporator, low refrigerant charge, high suction line pressure drop, thermostat expansion valve not correctly adjusted, and then you got restricted or plugged liquid lines. And then you got normal temperature split. Normal temperature split is the high leaving air temperature. System is overloaded, bad compressor valves, oil separator leaks, low leaving air temperature, system lightly loaded, thermostat for low temperature, faulty low pressure cutout, okay, thermostat expansion valve superheat, high superheat, restriction in liquid line, low refrigerant charge, low pressure drops across valve, moisture causing icing at valve opening, incorrect setting of valve, okay, low superheat, valve seat leak, incorrect setting of valve, overcharge, insufficient air across coil, sensing valves offline or not properly secured to line. No. Do not under any circumstances attempt to adjust the TXB until all other parts of the system have been checked. Okay, I thank you very much for this your participation on this lecture, and this is the last lesson on this particular module, air conditioned, commercial, residential, and commercial. Again, I thank you again. Bye.